2.4. Identify Einstein's contribution to the quantum theory and its relation to blackbody radiation. So what we need to know at this time period was when Max Planck was coming up with the theory of the quantum theory, there was many scientists that disagreed with him. It wasn't accepted in the scientific community, and Einstein thought he could tackle the problem. So even Max Planck didn't even support the theory, which is also fundamental. However, there was something persisting in the scientific community, and Einstein was one of them to take it further. So in 1905, Albert Einstein applied Planck's idea of quanta to explain the photoelectric effect. He extended Planck's quanta idea to light. He assumed that light existed as quantized photons, which carried scientific quantas of energy. The energy of a single photon is E equals hf, and this energy is partly used to break the electron away from its atom. Einstein explained Planck's work in the following way. The energy associated with the radiation from the black body is concentrated in packets of energy called photons, which I just explained there earlier, and I'd like you to underline that. A photon is the smallest amount of radiation energy possible at a particular frequency. It cannot transfer part of its energy, it can only transfer all of its energy or none of it. The number of energy carried by a photon is proportional to its frequency. The intensity of light is proportional to the number of photons. The energy possessed by a photon is proportional to its frequency, hence the observation in relation to blackbody radiation, that the shorter the wavelength, the greater the total energy radiated. Einstein also explained that wave and particle behavior can coexist, which is called the dual nature or duality for light, which some conditions light can act both as a wave and a particle. Okay, and that came around those time periods of the 1900s. So Einstein was fundamental in Mach's contribution to the quantum theory and gave it a new purpose. And you can see that looking at Hertz's experiments when he was doing EM radiation, that most of those words in the diagram on the right hand side came up. So polarization, reflection, refraction, the photoelectric effect, which Hertz never embarked on, and it didn't take too long for Planck and Einstein to capture that idea and take it further. So this time period of the 1900s was full of excitement when it came to the quantum theory, and it really put classical physics behind in its adventures. And now today, when we're using quantum computers and using the quantum theory in practice, you can see how that was revolutionary 110 years later. So when you're looking at your worksheets, the photoelectric effect, you look at the Hertz experiment, you look at Max Planck's worksheets, just understand that all three link and they're all built from each other and supported each other when it comes to the quantum theory, photoelectric effect, and so on.